there are two different types of bonds that can form. The one that I just described is called an ionic bond. Because what happens? Positive and negative ions are attracted to each other. Because in chemistry, who's attracted? Negative and positive. Opposites are always attracted. Like poles on a magnet, right? Positive and negative, always attracted. That's an ionic bond. And then later on, probably next week, we'll talk about covalent bonds. Covalent bonds are sharing. Now, I'm going to use two analogies as we go through these bonding ideas, okay? Electrons can either be like money or they can be like children, okay? Here's the idea. Let's think about this ionic bond idea. If you're sodium, you have extra money to give away, right? Who takes that extra money? Somebody needs it. But then what happens once they take your money? They're always beholden to you, aren't they? They feel like they owe you something. They're attracted to you. You can't get rid of them. Right? Ever given somebody something and they like can't get rid of them?
Like a dog.
Yeah, like you feed your dog. Dang it, go away. Okay? Or when we talk about covalent bonds in particular, we'll talk about parenting and children and how the parents share duties of the children. Theoretically. It's not always even. Don't look at me like that. Because we'll talk about how it's not even sometimes. But that's sharing covalent bonds, okay? Ionic is like, here, you take my electron, I'm done with it, I don't want it anymore. Okay? So, on this slide, they have the M stands for a metal, and the NN stands for a non-metal. I want you to look at this slide for a minute. Don't write anything down. What do you notice up here? The metals are giving electrons. Why do metals give electrons? What did we learn in the last chapter? Why do metals give electrons? We learned something towards right at the end of that chapter.
They're reactive, most reactive.
They have more metallic character and lose electrons.
And they all have.
They lose electrons. Usually, what's the terminology for that? They have a very low
Reactive.
ionization energy.
We need to know that.
That'd be handy, huh? Metals lose electrons because they're easily ionized. They have very low ionization energy. Okay? So the metals give up electrons, and who takes the electrons? Non-metals. Remember in the last chapter? Non-metals have very high ionization energies because they're not going to give up electrons, they're takers. And I don't know why, I told the other class, I always think about male and female.
Oh, rough. Women being the takers.
Givers and takers.
Yeah.
Really?
Well, I'm a male, that's why I think of it that way, you know, but, I mean, y'all probably think of it the opposite way, right?
Oh.
Plus, M stands for male. Is that a good way to get out of that?
What is it,
For
NM
non-male.
Yeah, because there's only one important thing in the world, males, and then you have everything else, non-males.
Apparently they let you get.
No, that's not good, we shouldn't use that.
That's wrong.
I can actually.
That's wrong.
Big X, yeah.
That's wrong on Ellen?
You got your man and then your manly man.
No, you can't
Instead,
have
women
that.
are never
You
takers.
can't have that, because in chemistry, you can't have two males or two females, you have to be opposites.
It's
I can see it as a parent.
It's just like the plug-ins, you got a male, female, a male, female plug-in.
We're not gonna go there.
At least he didn't say master and non-master, then I would be worried.
Well, you know, there is a utopian world that will exist one day like that. So, one, the metals are the givers. Okay?
Yeah.
The females. If you want to call these the females, they're the givers.
Don't confuse me.
I don't know.
We can say them.
Well, I'm not gonna go there. I'm trying to be nice for today. Well, I'll talk disparagingly about my ex-wife later on. Okay?
Well,
Oh, yeah, you're one of them.
what happened there?
When we talk about
You don't want to get a
covalent
bunch of women
bonding,
started about
Oh,
me.
okay.
when we talk about
Next
there's
class.
not even a guy in this classroom.
No, you're in trouble.
Yes, so you just like cooking.
when we talk about covalent bonding, we'll talk about my ex-wife.
What the heck?
So, here's the metal, the female. Go give up the electrons because women are givers, right?
All the time.
That's it, yeah.
Well, now I don't write down the down.
Yeah, they give headaches, they give, let's see. And what happens with the non-metal? The non-metals are the takers in the world.
Yeah.
They take electrons. So the metals always become positively charged. And the non-metals become negative. Once again, non-metal, see, that just works. Females are negative, you know, that works for me. But then again, I'm a male. Y'all probably think of it the opposite way, right? Okay, however you want to keep it straight. Metals always become positive, non-metals always become negative. Now this is when we have ionic bonding, okay? Now, when you have covalent bonding, you have two non-metals coming together. And they share electrons. And we'll get to covalent bonding soon. Next week, probably. Well, how do you know how many electrons an element is going to donate? We said earlier that sodium gives up one electron, right? Well, let's look at the electron arrangement for sodium. It was what, 281, right?
Yeah.
Every element that's in group 1 has one valence electron. We said that last week, didn't we? Every element in group 1 tends to become 1 plus. Okay? Does that make sense? So if you have your periodic table, this is what I do to it. Write those charges on the top of it. When they become ions, group 1 becomes 1 plus. What do you think happens to group 2? They're metals, aren't they? So they become positive, and they become 2 plus. 2 plus. Not plus 2, but 2 plus. I know it doesn't make sense, it's a detail. It's 2 plus, not plus 2. Because we're not adding. Okay? Now, look at group 3. It starts off with a metalloid, right? Boron. Underneath that is aluminum. Aluminum is always 3 plus. The ones underneath aluminum, don't worry about right now. We'll get to those. So,
Aluminum is always 3 plus?
aluminum is always 3 plus. Now let's look at the non-metals. We talked about chlorine earlier, right? How many electrons did chlorine want?
One.
What's 1 electron? So do you think that applies to anybody else on the periodic table?
Everybody in
All the
group one.
halogens?
Everybody that's a halogen, right? Everybody's in group 7A,
Oh,
right? Everybody's in group 7A is a halogen. They will always be 1 minus. All the nonmetals in group 7A will always be 1 minus when they form an ion. Okay? What about group 6? Yes.
what group?
7A. Halogens.
Okay, so we have
1 negative.
1 negative.
Because think about it. Everybody in group 7A has 7 valence electrons. They only need 1 to have a full valence shell, right? True?
Does group 7A include the last 2? Even though that
No,
was.
we don't. No, those aren't metals. Those aren't non-metals.
All right.
Those are metalloids. Now, what about group 6A non-metals? How many valence electrons does 6A have for the non-metals?
6.
It has 6 valence electrons, right? So what charge do you think it formed? 2 what? 2 negative. Why? Because it needs 2 so that it has a full valence shell, right? Does that make sense?
Yes.
Sorta? We're getting there? All right. What about group 5? 3 what?
Negative.
3 negative. It's non-metals. The non-metals in group 5 become 3 negative. Okay? There's only 2 of them, nitrogen and phosphorus.
The thing that is after the number.
Yes. Yes. So when you're doing mastering chemistry and it asks you for the ion formed by magnesium, it's Mg2 plus. Mg plus 2 is wrong. Yeah. It's 2 plus, not plus 2. Because we're not adding, this is the charge. It has 2 plus charges. It's not adding 2 things. I know it's semantics, it doesn't, to you guys, these 2 things probably look the same. To most people in the world, they look the same. To chemists, they do not, okay? Just take my word for it. Did I tell y'all we're gonna leave at 10 till?
And if I can't stay in the computer room, and they're gonna lock it down.
They're gonna close the
I just check
campus.
it out.
Yeah.
I think they were.
They're closing
So
the
they're
campus.
closing the college.
They're gonna lock everything up,
I
yeah,
got you. I
So-
was wondering.
okay. So, we already talked about sodium, right? Group 1A becomes sodium plus, Na plus. We talked about magnesium. Group 2 becomes Mg2 plus because it's going to lose 2 electrons. Nonmetals become negatively charged as they gain electrons. Come on. Now here's a good summary table, right?
Boron be?
Boron is a metalloid. It doesn't form ions. Aluminum is 3 plus. Aluminum is 3 plus. We were talking about things when they form ions. Boron doesn't form ions.
Okay.
And you know, we didn't put anything above carbon, did we? Because carbon doesn't form ions. Think about it. Carbon's got 4 valence electrons, right? So if you're carbon, what are you doing? You're sitting here in the middle and you're going, do I lose 4 or do I gain 4? Lose 4, gain 4. It can't make up its mind, so what does it do? It doesn't form ions, okay? Carbon rarely forms ions. We won't talk about any examples in this class where carbon forms an ion, okay? It just doesn't happen. Now look at this table up here. It summarizes what we just said with the charges on the main group elements. But there's an extra column up here. Anybody see the extra column up there? What's the extra column? There's 3 columns. There's a group number, the cation symbol, and then the name of the cation. Let's look at the cations. Let's look at the metals first. What's different between the name of the cation and the name of the metal? Do what?
Symbol after it.
No. I'm talking about, who said that? This column right here versus the name of the metal. It's the same thing, isn't it? So you don't know if I say lithium, if we're talking about the lithium ion, or if we're talking about lithium metal, okay? You would have to put that word ion on there. The lithium ion means lithium plus, versus just lithium implies metallic lithium, okay? Now, the nonmetals are a little bit different. They change their names. Look at the names for the nonmetals. They end in IDE, don't they? Like sodium chloride, your table salt, everybody knows that's called sodium chloride, right? Okay, it's not sodium chlorine, that's right, sodium chloride. All of those, when they form anions, change their name ending to IDE. Okay, does that make sense? Now some of them you guys know of, or you've heard before. You've heard of iodide and chloride. You've probably heard of an oxide, maybe. But you've probably never heard of phosphide or nitride, and you will get them confused, okay? You've probably even heard of sulfide. Where do you hear about sulfides? Anybody know anything about sulfides? Smelly. Stinky. Sulfides stink.